Hello. Feedback, feedback? Yep, feedback. Okay, yes, walk away from that. Hello. How's that? Yes. All right. Pacing, pacing. Pacers. Good. Okay.
check, 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 1 2, check, 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 test 1 2, check, check. Check, 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 test 1 2, check, 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 test 1 2, check, check, test 1 2, check. Check, 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 test 1 2, check, 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 check. Check, 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 test 1 2, check, check, check.
Hi, everybody. Okay, so remember that clapping thing we were doing? I want to see if it works for actually trying to get people to come into the room. Let's see. Okay, so just start clapping, please. Okay, clap. Raise the volume. Lower the volume. Raise the volume. Lower the volume. Okay. We had a thing where we do that, and it's a clap. Okay, pull it. All right. Now, you guys over here, you're going to go. Okay, let's do it. Okay, yeah, it's working. Good. Let's see. We have to figure out what else we can do. Let's see some drones. How about that? Yeah. Am I up? I'm up. Okay, it's my privilege to introduce Sarah Pearson from the Department of Foreign Affairs and Trade of the Government of Australia. And Sarah is a seasoned creator of innovation ecosystems, bridging public, private, and nonprofit goods, bridging technologies, and actually driving solutions towards real scale. And so I'd like to have Sarah come up and give us some remarks as we look at these scale-up awards that we're about to start evaluating, or potential scale-up awards. So over to Sarah. Thank you.
Thank you so much, Brian, and thank you very much for the invitation to open this part of your event. It's a really exciting part of the event, and for me, probably the cornerstone. I think entrepreneurs and how entrepreneurs create impact at scale is such an exciting opportunity. So it's good to be part of your Inspire Challenge pitch event. And you know, it's really great to see an entity such as CGIAR looking to take entrepreneurship models to help translate research. So this idea of getting ideas and research out into impact is something that is a bit of a holy grail that people all around the world are trying to make work. So I've just been hearing about the model that you've been using, and it sounds really fantastic. As was said, I'm the Chief Scientist and Chief Innovation Officer at DFAT in Australia, and as such, I get involved in foreign policy, in aid, and in trade. So I have really quite a ball of a job working in all sorts of areas. But the piece that I think is most pertinent to today, and what's just about to happen, is the work that we do with entrepreneurs. I have a very strong passion to empower people in the Indo-Pacific to solve social challenges through the commercial models that entrepreneurship offer to them. So solving challenges such as for health, for education, for nutrition and agriculture, such as some of the ones we're going to hear today. And it's so important, I think, to not only invest in those entrepreneurs, but to make sure that you can help them scale up. So some examples would be in Indonesia, there are a range of fisheries, there's thousands of fisheries, and they have a challenge in understanding when to feed the fish. It's actually one of the biggest costs of e-fisheries. So a fantastic entrepreneur has developed an IoT solution to this using sensors that understand when the fish need feeding. We've also invested in people who are doing robotics for agriculture and a range of other agricultural techniques. And drones. Obviously, drones are very popular. We've invested in drones that do things like looking at land use and how you can change your land use. But the piece that I wanted to talk a little bit about was that scale up. So yes, you can have a great idea, but how do you take that to scale? And there's so many things that a startup will need to take their ideas to scale. What you're doing here this week and today is such a key part of that. You really need to help entrepreneurs to think about their business model. It's great to have a tech idea, and it's fantastic to base that on data, but then what business model do you use to make sure it actually has the impact, that it gets to customers and consumers and makes a difference in the world and builds economies? So really fantastic to see what you're doing here. Some of the things that we're doing in DFAT across the world is to actually build the whole innovation infrastructure. So we're working, for instance, with 31 accelerators across 19 countries in the Indo-Pacific, really trying to build their capabilities so that you as entrepreneurs will have somewhere great to go to help you scale up. We're also working with entire countries on their entire national innovation systems, so looking at what policies you need to put in place, as well as the accelerators and the incubators, the venture capitalists, the cultural piece that you need for a whole ecosystem. And we've been doing all of that with a gender lens. I'm sure it's fantastic to see so many women here, but it's really, really important to draw women into this new economy based on entrepreneurship. If you look at the statistics, 75% of future high-growth jobs will need science, technology, engineering, and maths, and 65% of them don't exist. So that means entrepreneurs and techies are going to be so important for our future economies. Sadly, women are underrepresented in both STEM and entrepreneurship. So how do we get the systems to work really well for men and women? And like I say, it's fantastic to see so many of you as women in here today. Your event today is a real classic example of helping to build the capability. I talked about that, your business model, but it's also learning how to pitch to investors. There's a real art in learning how to pitch. I'm actually on the investment committee for an entity called Main Sequence Ventures, a $200 million fund in Australia that is helping to translate research ideas into startups and scalable businesses. And in fact, one of them was here yesterday, Fluorosat. I don't know if anybody met Anastasia, but she's an absolute bombshell. She's fantastic. So the sorts of things that you're doing about pitching and learning how to look to tell your story is really, really, really important. And as you look around the world for where the heart and the cornerstone of these fabulous ecosystems is actually the research base. So it's fantastic to be here on the site here with my fabulous colleagues in the front row who are involved in research and are keen to see that translation. Really, really wonderful to see. You see it from Silicon Valley. You know, Stanford was the cornerstone of Silicon Valley. And then if you go through Israel, the startup nation, the Weizmann Institute, Cambridge University in the UK. And of course, here in India, you have your centres of innovation, sorry, your institutes for innovation. I went to see, I have to remember the name, it was only Monday, and I'm in a bit of a whirl, I've seen so many things this week. The Centre for Innovation, Incubation and Entrepreneurship at the Indian Institute of Management. And I've seen one of your hubs here today. It's just an amazing amount of institutional activity going on. Really fantastic. So, today is a great event, really, really important. But you know what the most important part of today is? It's the people. And I see this again and again from Port Moresby in PNG, through to Myanmar, through to even Canberra in Australia, which is where all our public servants live, and it's a bit of a, people think it's a dead town. But the people that are making innovation and entrepreneurship happen are really, really important. The passion, the commitment, the collaboration, and the resources that people bring together in connection. And if there's one thing that you're doing in this event here, it's connecting, so that you will be able to scale and grow and find routes to market, and that's incredibly important. But of course, the main people are the entrepreneurs. And I am so excited to have been able to open this little bit here, talking about the entrepreneurs and the pitches that you're going to do. Sadly, I have to go and do some other things. I'm only in India for 4 days, so I'm rushing around seeing all sorts of fabulous activity and getting to learn about the scene here. So I won't be able to see the pitches, but I'm looking forward to hearing about them, and I'm sure that I'll be able to see the videos after the event and find out what you're all up to. So thank you very much again. Good luck, pitch well, and I can't wait to see your company scaling into a national and then a global basis. Thank you very much.
Okay, let's get going. So this is, I must admit, the favorite part of these conventions. I love the Inspire process, right? You get to see these amazing ideas, innovative, kind of risky stuff. You know, I personally, the best thing for me is to be surprised, and I've been surprised several times during these processes over the last 3 years. So we have an Inspire process which consists of two kind of stages. The first stage are pilots, and we'll be looking at those tomorrow. A pilot gets funded with $100,000 and then and has a year to go out and kind of prove as a pilot that this is something that is kind of innovative, it's doable, we have risk appetite, so it's fine to fail and say, oh, it didn't work. But the idea is to invest in these kind of innovative ideas that are going to solve intractable problems, right? Once you graduate from that pilot, this is the second process, is for scaling up. And scaling up really we see this as the next stage in the process. It's still experimental in nature, but it's going from proving that the pilot has worked, you've got something, and that this is going somewhere. And so for this scale-up process, it's then about additional investment, additional support, going up to $250,000 to go after that potential, that next stage. And so we're going to hear today from 7 potential scale-up pitches. And so these are graduates from the 2017 process. So there's 2 who are pitching who were won 100K during 2017, and there's another 5 from last year's cohort from Nairobi who've had a shorter time, but they've had the year since Nairobi to work on their projects. So it's an exciting moment. We get to see what they achieved in the first round and where they see this going. So we have, I mean, they've put together proposals, and so we have a judging panel who've looked at the proposals. We're going to see the pitches, and we're interested in getting feedback from everyone on the pitches, and I'll introduce that in a second. If we can put the Menti up so that people get ready with your phones. So there's audience participation here. We need that feedback. And then we also have the booths, and so they have everything from posters to demonstrations and a really lively atmosphere over there in the booths. And so the idea is that you interact and question those groups. And we have an illustrious judging panel who will be using all of those inputs to come to a decision, which we'll communicate tomorrow night in the awards ceremony. Okay, so just to introduce our illustrious judges, we have, and I'll go in order here, Pete Richards from USAID. We have Yvonne Pinto from A-Line Impact. We have AJ Coley from IRI. We have Kate Pfahlenberg from Sea to Shore Alliance. And we have David Bergvinson from AWARE. If you can just stand up so that they can be seen. No lobbying. All right, no lobbying. No, lobbying's not allowed. We'll deduct points. So, as I said, what we want to have is the inputs from you as the audience. It could be just simple ones like, this is great, or like, well, you know, terrible, or let's be nice, not necessarily terrible, but, you know, needs a bit more work. And suggestions, how they could improve it, right? Because this is an incubation process. It's not just a blind review of a project. Give them ideas about how you might take this forward. So we have this Menti. There's going to be one for each of the pitches, and we'll provide that input also to the judges. So please do participate and provide some feedback. So without further ado, the format. We have 7 of these pitches. Each one, they have 7 minutes. And we're going to be very strict with that. When there's 1 minute left, Ceci down here has got a beautiful 1 minute hand-drawn 1 minute note there. We're going very digital with this. When you hit the 7 minutes, I'm afraid there's going to be a noise. And so the livestock data for development group have provided me with Harold. Apparently he's called Harold. Harold will sound at the 7 minute zone, and you've got to stop. Okay, so there's no, we want a level playing field for everyone. You got 7 minutes, and then you got to stop. Okay, so this will be the note to stop. Is that loud and uncomfortable? It's meant to be. Okay, so without further ado, we'll go to the first one, which is going to be put up here. It is, let me just get the full title, Informing Food Flows with Wi-Fi. Wait a minute, let me get the title. Revealing Informal Food Flows Through Free Wi-Fi. And we have Thibaut coming up. And so we got all the tech ready. We want a level playing field. Are you ready?
No, but we'll do it.
So we have this. This is for changing the green one.
Okay, and then going back?
And going back is the red.
And the laser? Here. Okay.
Okay, all set?
Okay.
Go.
So hello everyone, so I'm Thibaut Ventalon, and today I will present you the ICRISAT challenge that we implemented this year and how we're planning to scale it up. So the name of this challenge is, I will say all the word this time I hope, is revealing informal food flow through free Wi-Fi. And the main local partner for this challenge was the General Statistics Office of Vietnam. And while you can see a long list of names of people implementing it, today we are only 3 here present with you. There is Dharani and Kian. Okay. So it's working cool. So what we did is the following. So we equipped 5 traditional Vietnamese markets with free Wi-Fi. But there's a catch. Nothing is free in life, and what we did is the following. When people want to connect to the Wi-Fi, we have a little bit of the time. And during this time, we're asking them 1 to 3 questions. And thanks to the device MAC address, which is a unique ID, we can tune the question we're asking. And we remember what they said before. So for example, if someone told us, hey, I'm a food seller in this market, and we see it the morning when they want to connect, we'll ask them, hey, what did you buy from the wholesaler this morning? And in the evening, we go back, when they want to use the Wi-Fi again, we'll ask them, oh, cool, and what did you sell today? So we can really have really fine-tuned question and track food flow thanks to that. And on top of that, since we have those access points in the market, we can do something else. So if your phone is old enough, it will reveal its presence. And the access point can scan for the phone, and so we can track people. We know when a device is in the market, for how long it's in the market, and if it's moving from one of the market to another. And so during the pilot phase, the data we got are the following. So we got a lot of data. So we got almost, that was last Friday, after 76 days of running in production mode, we got almost 40,000 individual user answer. And the device we tracked, we got 61 million occurrence of different devices, also the same. Every 2 seconds, we got a report on the device the access point is seeing. And if we transform that to a number of users, we have roughly 3,300 different users answering our question, and we have roughly 1,000 people seen in the market. So today, I will mainly focus on gathering data from those users. But at the end, we have the user time. So we can, on top of gather data, we could also advertise for good practice. So if one of our users is, for example, telling us that his store is not certified for food safety, we could show him an ad, a little bit like YouTube, no? Wait 7 minutes before getting to the internet, or 7 seconds. And this ad could explain to him why it's good to be certified and what he can do to get this certification. So what we realized during this pilot phase is that we have a highly scalable and highly flexible system to gather a lot of data and gather this data in real time. So how does it look like in practice? So it looks like that. So you have one bit of the database. So there's 3 columns. The first one is a signal strength. So it's a proxy to the distance the device is from the access point. So that allows us, for example, we don't want to monitor the traffic jam next to the market. We want the user in the market. So thanks to that, we can limit ourselves to people in the market. And also the MAC address has some information on the device the user is using. So we know, for example, that the first guy on the list has a Samsung phone. And of course, we are gathering a lot of personal data. So we did not just do it, but we went to the internal review board and we got the approval. And also, we're really careful and anonymizing the data. And then you can see in the middle picture how we're advertising the project in the market. So we installed some banner and distributing some flyer, telling more about the project. And finally, you have the login page. So that's the first question every user gets the first time they connect to the Wi-Fi. And basically, we're asking them, what are you doing here? Are you a buyer? Are you a seller? Are you a wholesaler? And so on. And there's also 2 links in blue. That's one is asking them for their consent, and the second one is telling more about the project. So now we want to scale up. And the way we want to scale up is the following. So first of all, right now we have 5 markets, but we want to double the number of markets. And we have mainly market in Hanoi, but we would like to go to assembly markets in nearby province, and that would allow us to really track the food flow into Hanoi. And then we want also to get all the wholesale market in Hanoi, so we get a better idea of how the food is distributed. And then we would tighten our relation with the General Office of Statistics to define some indicator. And then, thanks to a dashboard that we're coding, GSO could monitor those indicators in real time and report them to the Ministry of Investment and Planning. And this ministry will draft some policy and implement them. And since we got a system which is really cheap to maintain, we can track the effect of those policies in real time. And then we have a feedback loop because we're monitoring the effects and see if it's good or not. And it's a pretty big deal because most of the food getting to Hanoi is going through those traditional markets. So we would have, while we don't have all of them, we'll have a good proxy of what's going on for more than 80% of the population in Hanoi for the food. So as a proof of concept that we can monitor impacts and we can monitor seasonal events or extraordinary events, I have this one for you. So one morning, we check the access point in one of the markets and we see that none of them are working. And we wonder what's going on. And the answer comes pretty quickly when we look online on some newspaper websites, which are in Vietnamese, and we saw the picture you see, oops, in the corner. So I cannot, yes, in the corner. And so, big fire in the market. So then we understand why there is no electricity, but more interestingly, we can look at the question we were asking. On one question was, what do you think is the main weakness of the market? And you can see that before the fire, you cannot see except you have really good eyes, people were worried about food safety and food traceability. But just after the fire, things have shifted, and now the main worry of the user are the market infrastructure and the market management. And that's all. Thank you very much.
Okay, thanks. That was fantastic. All right, so we're not doing questions in this time. No, the judges are just kind of listening. People are commenting. You've got another kind of 20 seconds to do your comments while we introduce the next one, and then we'll move the comments onwards. Next up, we have, it's an easy one to introduce, and it is Kubica. We got the thing up? Okay, we're on to the Menti. Get yourself ready.
Red one, right?
Yeah, green.
Yeah, green one, sorry.
Okay, go.
Hi everyone, my name is Christophe, and today I'm here to represent QBK. So QBK is an intelligent digital advisory system that is built by a consortium of 3 different parties. The first one being Dalberg Data Insights, that is bringing the data science expertise in the project. Then we have Viamo, that is giving access to an existing digital advisory solution, as well as an existing network of 5 million users. And then finally, Bioversity International, that is supporting the project with extensive experience and connection with rural advisory. During this presentation, I will touch upon 3 different dimensions, which are the solution itself, the piloting, and then finally the scale-up, as you can see in the bottom right. But let's start with the story of Brian, who is a banana farmer who lost his banana production this year due to a disease. And actually, Brian is a fairly advanced smallholder farmer who is using a digital advisory solution, which is the Viamo 3-to-1 service. But this year, he couldn't access to the right information. And this is due to the fact that the Viamo 3-to-1 service is very static over time, but also from a user to another one, which makes the information not always accessible and not always relevant. Let's now look at Dembe, who is living in the same village and who experienced the same disease outbreak, but could actually access the right information at the right time through QBK. And this is thanks to the integration of an artificial intelligence in the back end of this solution. But let's look at this artificial intelligence. So we are talking here about a recommender system. Think about what Google is doing, for example, when they reshuffle the structure of the Google search based on your previous searches. Here it's exactly the same. The recommender system will basically look at different data points in order to predict the user needs and wants in terms of information. I also would like to emphasize on the fact that this solution is very inclusive, as very accessible on any kind of device, even without internet. I've been talking about the solution, and I would like now to talk about the piloting itself. Over the last 12 months, we piloted QBK in Uganda with 3,000 farmers. And this piloting could actually help us to validate 3 main assumptions touching upon the go-to-market strategy, the value proposition, as well as the operating model. We first validated the fact that the farmers actually need more relevant and accessible information through such a solution. And this is backed by 60 in-depth interviews. Then, in terms of value proposition, we validated the fact that our model is able to successfully predict the user needs and wants. And we looked at 20 different key performance indicators of the Viamo 3-to-1 service, such as the number of messages listened by the users, and we saw an improvement ranging from 5 to 10% for those 20 indicators. And then finally, in terms of operating model, we also validated the fact that this solution is sustainable because the incremental operating cost is affordable for Viamo. In Uganda, we are talking about $300 per month to make it up and running. Now I would like to touch upon the scale-up. I just presented the piloting. In terms of scale-up, we have the ambition to scale this to 5 million people, as well as 17 countries, touching upon more than 10 different crops. This will be done through different phases that will be led by the different parties of this consortium. This leads me to the impact of Viamo, and in this case, the impact of QBK, sorry. And in this case, actually, we foresee a very important and massive impact in rural Africa and Asia. We took here the example of the metric of the number of messages listened, and the deployment of this solution will actually bring additional 2 million key messages listened by the users. We also would like to emphasize on the fact that QBK will help us to mitigate, by essence, will help us to mitigate the main risk of partnering with telecom operator by continually improving on our value proposition. And I will close this presentation on the budget and the timing. To be scaled up, QBK will require $312,000 as well as 9 months. On this slide, you can see the way we plan to invest the budget across the 3 different parties of the consortium, as well as the 4 different phases, which are the design, the development, the deployment, and the sustainability. And one last point we really would like to emphasize on is the fact that QBK is a financially sustainable solution through the fact that the operating cost is affordable for Viamo and will be covered by Viamo after the deployment of the solution and after the end of the budget. Thank you very much.
Okay, thanks a lot, QBK. Harold was a little bit upset there that he didn't get to feature. Last 10 seconds for this. We're going to start getting the next one up. Link it. Okay, so the green one advances that one back just in case. You ready?
Yep.
Okay, go.
Hello, everyone. The agricultural value chain in Nepal is disaggregated and informal. This impedes the flow of information and resources to and from smallholder farmers. I'm Elise Dykstra, and I'm the Nepal country manager for Viamo. We're a mobile strategy firm, and we've partnered with Summit to address these gaps in information to smallholder farmers. Our original vision for our product was to create a mobile platform where buyers could post their products for sale and buyers could then bid on those products. The highest bidder would then be able to purchase that product. As we went to the field, we quickly realized that this wasn't going to work. Farmers rely on relationships and trust in those people buying their products because they don't immediately get the money from the products. They have to wait for the goods to move further up the value chain before the money trickles back down to them. For this reason, they need to trust the people that they're making transactions with. We had to pivot away from doing a platform of transactions to a platform that connected the farmers with stakeholders in the value chain. The resulting solution is Link It. The way that Link It works is that users call a toll-free line. They then hear an introduction to the service in their local language. After the introduction, they're able to register for the service by answering a few profile questions. They use their keypads on their phones, no matter how basic, to respond to these questions. We then look at their profile, match it with stakeholders in our database, and send an SMS message to the farmer so that they can make those connections. We piloted the service on our 321 platform. As you heard earlier, 321 is an information source that's not only on agriculture, but it goes across sectors including health and weather forecasts and financial literacy information. The 321 platform is partnered through a partnership with a mobile network operator. This allows it to continue to be free to the end user and promoted at the national scale. During our pilot on 321, in just 3 months since 321 launched at the end of June, we were able to have over 9,000 people call in and listen to the introduction of Linkit. Of those that listened to it, half of them went on to register for the service, which resulted in over 8,000 linkages being made. We saw that there's an appetite for Linkit, but we also wanted to see what the impact of those linkages were having on the farmers and the buyers that were included in the pilot. We did a survey, and we found from that survey that the impact was creating more sales and higher profits for both stakeholders. We found that 30% of the farmers had made contact with at least one of the buyers from their matches. Of those, 54% were able to make a sale to the buyer that they called, and 50% of those farmers reported higher earnings from those sales. On the buyer side, 22% reported that they had been called from a farmer. 41% of those were able to purchase goods from those farmers, and 74% said that they had higher earnings from using this service. During the pilot, we manually matched all of the different profiles. Once a week, we would download the data for the different groups, match the farmer groups with the different buyer groups, and send the SMS message. This limited how many questions and how specific the user profiles could be. We need to build out an AI system that would automate this matching, as well as the SMS to be sent. Once this is done, we can further tailor the profiles to get more specific and smart matches that will lead to a greater impact. By having the SMS automated, it will also increase the likelihood of the farmer acting on the information because they'll receive it immediately after registering for the service. The unique thing about Viamo is that we do have the 321 platform. We not only have it in Nepal, but we have it in 16 different countries throughout Africa and Asia. This gives us the opportunity to replicate and adapt Linkit to other markets and scale it beyond Nepal. It also gives a unique opportunity for the end user because they're not only getting market information, but it also has agricultural advisory information, all on the same service. All of the data from Linkit will flow in real time into an online map. This map is hosted on Summit's website. They have a data portal already in Nepal, which includes soil map and a crop suitability map. So now farmers have all of the information they need in one place to decide which crop they should be growing, not only from their climate, but also from market demand. It also has implications outside of the farmers and the buyers locating goods to the scientific community to be able to use the data to inform policy decisions, development projects in the future, and so on. Please join us in empowering smallholder farmers to make linkages to markets. Thank you.
Okay, thanks a lot. Fantastic. We're 3 down, 4 to go. Reaching the halfway point. Up next, Plant Village Nuru. David. Go.
Great. Good morning, folks. So this is a project between ourselves at Penn State University and the Roots, Tubers and Banana program of CGIAR. So what we're doing is trying to focus on a key constraint, which is diagnostic services of crop diseases for smallholder farmers. So in order to enable this, we developed a convolutional neural network, an AI assistant called Nuru, which is Swahili for light. And this runs inside a smartphone, which is 100% offline, so no internet connectivity required. And we benched our AI against human intelligence, so AI without human intelligence is just artificial. So we bench it against IITA experts, and our diagnostic services is as good as an IITA expert. So this means that farmers like Rosalind in the foreground, who was helping Emiliana in the background, is simply walking around with an IITA expert on cassava diseases inside her phone. And we found that when we do this, we can have a diagnosis, but then also importantly, also offline, we have an algorithm running inside the phone which provides advice from UNFAO or CGIAR, and this also takes into account the farmer data, so the size of her field, her practices, and so on. Now we focus on the lower end of the pyramid, 80% women farmers and 100% individuals who are on less than $2.50 a day. And when we give the power of an expert in your hand, we see amazing things happening. So Josephine was a farmer, like many, who traditionally got infected material from her neighbors, or also charities, or also governments. This is a 40-year-old problem. And she, all by herself, invented a solution which was using the app, again, offline, multiple times, and one day 31 times, to positively select clean material from which she replanted. And we've repeatedly gone back to her farm, and we see she has a 1 acre field with not a single infected cassava plant inside it. This is really impressive. Other farmers, like Berta, who's a school teacher, have shown how the single phone serves a whole community. And so Berta traveled to 23 different farms, so it's rather typical for the women that we give phones to. And she repeatedly has requests through word of mouth from neighbors who ask that she brings the Nuru phone in order to have the diagnostics. What we're finding through our co-designing process with farmers is that farmers truly trust the expert system, and they want to have the expert system, and they understand the background to that. Now, we were a 2017 applicant, and we pitched last year. We didn't make it, but in the intervening year, we've scaled up with the United Nations, and I joined FAO as a staff member, and I'm still there, and split between FAO and Penn State. And we gave our IP, which is a public good, to the UN. And we've scaled up for fall armyworm from West Africa to China across 70 countries and 21 languages. So we've been able to see an awful lot of data coming through this, 1.8 million plants checked, and we're starting to see some really interesting data about what manages fall armyworm for smallholder farmers. So this is a really exciting collaboration. More importantly, if you're using a single app in multiple languages from West Africa to China, you get an awful lot of surplus data coming out from which you can understand how it differs between Benin and Malaysia, for example, in user interface and design, and so on. Unfortunately, 2019 showed us just how important climate change was for smallholder farmers in Africa, 96% of which have no irrigation in their system. So we integrated our current AI system into the UN FAO tool called WAPR, which is looking at data from Landsat and MODIS every 10 days with a 10-year history. And so what you can see here is a year-long data of above-ground biomass, and you can see that fluctuation, and that's due to the twin cyclones in Mozambique in March and April, which took out about between 50 and 80% of the moisture from the atmosphere. So at that period of time, our farmers were just planting, and a number of farmers had planted maize multiple times, and multiple times it had failed. And so we started to consider this long history of data and asked to what extent we can do machine learning to kind of approach that problem. So the initial work that we're just kind of done over the last month or so is that we can predict with a 95% accuracy the evapotranspiration stress at a 100-meter resolution on any farm in Africa for the next 10 days. So imagine if we had have had this tool back in April when the cyclone took that moisture out of the atmosphere, that we can provide a climate change AI tool. And so even though Nuru and Plant Village was built for crop diseases, the effect of climate change means we have to really structure everything within that context. And the way I sort of think about it is that it's really just lipstick on cancer. If you're not actually approaching the problem of climate change, you're really not doing a service to the farmer. So you have to contextualize everything in that framework. Now, for those of you who understand evapotranspiration, you understand it's contingent upon the type of crops which are in the field. So we've also developed a new system where we can massively upscale ground-truth data by employing 10 Kenyan students from an agricultural university at $150 a day. And they're collecting between 200 and 300 farms, and that's immediately uploaded into the cloud the same day it's collected as a global public good, so that we can start to automate crop detection through Copernicus and so on. It's a fundamental constraint we have in the system, is that people are not sharing their data adequately well. So in addition to the fields which are being uploaded as polygons and the composition of those fields, we're also uploading a lot of images around that in order to enable detection, for example, of exposed soil, which is critically important for evapotranspiration. So why are we back again to apply? It's we were rejected last year. It's not that I particularly like rejections, but I think we've come back because we're looking at roots, tubers, and bananas, yams, sweet potatoes, and cassava, and these are crops which are grown by the people at the bottom of the pyramid. We have shown the ability to develop an expert system in the phone. We have shown the ability for farmers to use that effectively. And with scale-up funding, we can show how we can do this for yams, sweet potatoes, and bananas. And this is critically important, and that's why we wanted to scale up funding. Thank you.
Okay, excellent. 3 more to go. Machine learning for smarter seed collections up next.
Well, hopefully we'll hear Harold now. Okay, so my name is Oscar Marco, and I'll be presenting a project called Machine Learning for Smarter Seed Selection, which was done as a collaboration between CIMMYT, Biosense, and Crops. So every year, farmers are confronted with the decision what to plant in their fields, and it is an extremely hard decision because there are hundreds of different varieties and hybrids out there, and that's like paradox of choice in agriculture. They don't know which one to plant. But it's not only the risk, the profit they want to increase, it's also the risk. And there is a lot of risk from climate change, from pests, from diseases, droughts, floods, etc. So the way we're trying to solve this problem is by using big data. And so we had 2 data sets at our disposal, which CIMMYT gave us. So the first one was the hybrid data set, which had more than 15,000 samples with more than 180 hybrids of maize, with the planting dates, yields, etc. And the other one was the fertilizer data set, which had information about the fertilizer used, the amount used, the planting dates, application date, and so on. But besides the data sets that CIMMYT provided, we also used the globally available open source data. And there we have the CGIAR, a global elevation model. We have the Copernicus climate change service with historical data of weather records. We have European Space Agency satellites. We have soil grids data, which is giving us more than 200 parameters of soil at a 250-meter resolution. So this is really a set of heterogeneous data where we're using machine learning to crunch the data, but we're also using agronomic knowledge to put constraints in those models. So we're using big data to predict the performance, but the essence of our approach is actually portfolio optimization. And this is something that we brutally stole from economics. So this is a theory from the 1950s for investing on the stock market, where the investors want to find the optimal trade-off between profit and risk. And a similar situation is in agriculture, where farmers want to decrease the risk and increase the profit. So there are 2 characteristic strategies here. The first one is Las Vegas strategy, and that's to take the hybrid with the highest yields But as a rule, the hybrid with the highest yield is also highly risky. So it's like all or nothing. And on the other side, we've got those hybrids with stable yields that are really resilient to pests, to droughts, but you're going to end up earning peanuts. So what portfolio optimization is giving us is the optimal combination of different maize hybrids, so we could diversify the investments, or like diversify the maize hybrids. And the good thing about it is that the farmer could be the wolf of Wall Street, because the farmer can now choose the amount of risk he's willing to take. And that's an example of portfolio of maize hybrids that we can recommend the farmer. So these are the results. So the results are quite amazing, I must say. It turns out that we can increase the yield for as much as almost 3 tons per hectare, and at the same time decrease the risk for 8%. And this has been validated on CIMA data. So 87% of farms witness the improvements, but the whole beauty of this approach is that the additional investment is equal to 0. So it's just a matter of which seed varieties and hybrids the farmer wants to choose. And what came up as a byproduct is the smart fertilizer application, where we realized that we can increase the profit for almost 50%. So we made a prototype of this, so you can actually find this at smartseeds.biosense.rs, and that's the prototype that we developed for Mexico. So with a single mouse click, a Mexican farmer can know what varieties to plant and how much fertilizer to put and what type of fertilizer to apply on his field. So it's incredibly easy to use, and there is a complex big data model behind it that a farmer can't see. And what we're hoping to do in the scale-up is to scale this up globally. So the only thing we need to do is to have the calibration data for a particular area. And CIMA has got data for Africa, for South Asia, India, of course, and we have the data for Southeast Europe. So this model is quite scalable, as we're mostly relying on globally available data, and we just need a tiny bit of yield data about hybrids to fine-tune the models. But we also want to include other crops such as wheat, sugar beets, sunflower, sorghum, depending on the area. So we want to have a multi-crop portfolio, so not just different hybrids of maize, but different hybrids of maize, different varieties of wheat, and different varieties of sugar beet, and so on. And to do that, we need to employ evolutionary algorithms. And the good thing about those algorithms is that they're giving us the opportunity to include other objectives as well. So not just profits and risk, but also the environmental footprint, subsidies, fertilizer amounts, price volatility in the market, and so on. And of course, we want to apply high-performance computing, because currently we need some 20 seconds to calculate the smart sowing strategy, which is not too much considering that the farmer needs to run this model once a year. But we would need some high-performance computing to do this for the whole world. And last but not least, of course, we have a sustainable business model, which is what we call the Robin Hood business model. So the idea here is to charge the big guys, the big farmers, the big cooperatives, and well, we're charging everybody with what they can afford. In the case of big farmers, it's of course cash, but the small farmers can also contribute to the system. They can get the recommendations for free, and they can give us back the yield data about the yield of hybrids that they saw in the previous year. So in this way, we have a sustainable model that could be applied anywhere in the world. Thank you very much.
Okay, thanks a lot. You know, Harold's getting a little bit upset here because you're all keeping to time. I was looking forward to using this, you know. I guess you'll have to go to the livestock session to get more of it. Okay, up next, tracking fish in food systems.
Good.
Green moves forward.
Thank you. I know, fish, you're all thinking, how did he get in here? So this is tracking fish in food systems. This is a project in partnership with WorldFish, Pelagic Data Systems, that is private sector, and Wilder Lab, which does a lot of the coding behind it. So what this project is really about is trying to fill the enormous data gap that is small-scale fish production globally. This sector represents about 60 million fishers and farmers, all contributing to the diet of over 3 billion people. And it's incredibly important from a nutrition perspective to have fish in your diet, as I'm sure everyone in the room knows. So we really need a way to adequately quantify this sector and the production on in time and space. If you can't measure something, then you can't manage it. And this is very much the situation that we found in Timor-Leste, where we piloted this project. It's a small half-island nation at the eastern end of the Indonesian archipelago. And really, they're suffering from chronic malnutrition, especially in children, resulting in childhood stunting due to lack of micronutrients. And a lot of those micronutrients are found in fish, so it provides a potential pathway to combat this chronic problem. So we set out to create a free open access platform to provide data on small-scale fish production. Because the real challenge here is that they're so diverse, they're catching different species, they're often in remote locations, and so it's how do we tackle it technologically? So we decided to, with tablets and smartphones, collect fish at landing sites, and then we teamed up with Pelagic Data Systems, who developed a solar-powered, fully autonomous vessel tracking device, and so that gathers GPS information about where the fishes are going. And really where the Inspire Challenge funding was critical last year was really in allowing us to integrate those two things together, to look at how we can evaluate fish abundance over time and space. What it also did was allowed us to develop machine learning algorithms in two different aspects. One was really to gain greater inference on where they were actually fishing compared to where they were just commuting or steaming to their fishing grounds. So that's kind of using turning frequency, turning angle, speed, that sort of thing. And the other one was using nearest neighbor pattern recognition to kind of look at whether we can predict what habitats and gears they are active in, even if we only have the tracking data and don't have the catch. So the other aspect that the funding provided was being able to develop the dashboard, so the global public good. So these data are summarized, aggregated to protect sort of individuals and communities. So it's aggregated to municipal level. But also we were able to think about the financial sustainability of this, and with Pelagic Data Systems developed an augmented analytics dashboard, which would then be a subscription model to governments and high-value commercial fisheries that could gain very good spatial and high-resolution near real-time data on their fishery. This is really the first of its kind in the world for small-scale fisheries, just because of the difficulties I mentioned in the dispersed nature of fisheries. And it provides governments with the data they need to make informed decisions, to prioritize interventions, but also at the fisher level, the fact that this is open access means that it kind of empowers the voice of fishers in the clamor that is the blue economy. So through initial scaling in Malaysia, we found that this is a really crucial aspect because there are various land reclamation projects going on and coastal urban development. And the small-scale fishers are really fighting to have their voice heard, and this provides data on where they fish, how they build their livelihoods, etc. So I'm happy to say that actually in Timor, as of May this year, the government adopted this system as their national fisheries monitoring system and have committed to funding it from next year. And this was really as a result of strong partnerships. The partnership itself is an innovation because World Fish are working with the private sector to develop this kind of financial sustainability. So the idea is that clients will pay for the tracking devices and the subscription dashboard, and a portion of that will go to World Fish and Wilder Lab to maintain the open access dashboard, and to carry out the research around these systems and to upgrade it where necessary. So this is now planned to be scaled. Next week I'm in Odisha here in India to scale to a different system, which is inland stocked reservoirs. And this is really exciting. So what we need to do is really change to a different system in a sense. Still it's fish, but it's stocked almost aquaculture. And so we need to customize the components of the data pipeline to cater for this. And that's really where scaling funding will come in. We also plan to scale it within the World Fish Network, so these other countries. And we will look to carry out the kind of co-design process in Malawi and in Odisha and in Malaysia, which is our kind of home base. Other aspects really work on the dashboard to improve that kind of financial sustainability and improve those customized components at each stage so that it can be adaptable to different systems. Thank you very much. Sorry, you can tweet it if you want.
Can I do it? Just
Yeah, go on then.
Hey. Okay, whoever it was late. It's okay, we forgive you. So next up, last but not least, and just to say, we randomized the order, so there was no kind of, it was a random set of order. I don't know whether there's an advantage going first, middle, last, but whatever. And so, last but not least, we have use commercial microwave links to estimate rainfall for agriculture. Over to you. Go.
Good morning. So our project aims to use commercial microwave links to estimate rainfall for agricultural needs in developing countries. And here's the idea. When you speak using your mobile phone, you communicate with the closest base station. This base station communicates with the next base station, and so on until the signal is received by another end user found in some other location. Now, weather conditions and particularly rainfall affect the electromagnetic channel, causing attenuations to the radio beams. Thus, commercial microwave links can be considered as an already existing rainfall monitoring facility. Our objective is therefore to demonstrate the potential of applying this technology for agricultural needs in Kenya, Guatemala, and Indonesia, and to design a pilot rain insurance product in Guatemala using this approach. But why using this technique from the first place? So current monitoring tools are often insufficient. Rain gauge provide only point measurement, which is not representative of the larger space. Satellites may suffer from lack of precision when measuring near ground level. Radars suffer from clutter effects and from overshooting in many cases. And on top of these instruments are sparsely deployment across third world countries. As opposed, commercial microwave links are found everywhere, including in developing countries, and can provide real-time measurements from ground level with high spatiotemporal resolution, and the costs are minimal since the infrastructure is already there and the data is being collected by many of the cellular providers for quality of assurance needs. On top of that, there are no privacy issues since we are using only the signal strength between the base stations. Here is an example for the cellular coverage across Kenya as compared to the sparse deployment of rain gauges across the same country. So you can notice that we have there something like 3,000 microwave links that can measure rainfall as compared to only about 30 rain gauges. And let me show you some real data results. We have been able to receive data from these places. So first of all, this is our test site, which was situated in a tea farm in an agricultural field next to the city of Kericho in Kenya. And what we see here, each line represents the location of the microwave links, and the triangles represent the locations of the different rain gauges. So the algorithm that we have been developing during this year is able to generate rainfall estimates at any given point in space using an inverse distance weighted interpolation. And let me show you some comparison to the CHIRPS product, which uses rain gauges measurements and satellite data. So let's focus on this point over here where we have a rain gauge. So these are the results achieved by the chirps. These are the accumulated daily amounts as achieved by this algorithm and as compared to the ground truth, the rain gauges in that, location. As you can see, pretty convincing correlation, but not a very high one. As opposed, our algorithm has reached excellent results with very high correlation. And in addition to that, one may note that in some cases, the chirps was failing to detect rainfall in some areas where this algorithm was able, in accordance to the ground truth, to detect the rainfall in these locations.
I'll summarize what we have. What we have achieved in the pilot. We have established a collaboration to obtain the CML data from 3 countries in 3 continents, Kenya, Guatemala, and Indonesia. We also have developed the algorithm for rainfall monitoring and have demonstrated the value added of this technology. We also have built the stakeholder network in Guatemala with those entities. In terms of outputs, we have a peer-reviewed conference paper published and presented in the CEST conference. We also have a journal paper which is in final preparation for submission. We have 3 key findings. First, CMLs provide consistently reliable rainfall estimates, and they outperform satellite chirps in all cases in our sample. And the CMLs even outpace rain gauges in some cases. In next steps, we plan to develop infrastructure to automatically retrieve the needed data from the secular provider system. This is being tested with Tego Guatemala now. And we will investigate the algorithm, the capacity using the newly available data from the 3 countries, and to improve the algorithm, the precision. We will also develop and pilot the new rainfall insurance products in Guatemala. The product 1 would modify the conventional insurance by using CML rainfall to trigger indemnity. So we are basically using the high spatial resolution feature of CML to reduce the basis risk. Product 2 would be a brand new product to ensure the losses from sudden rainfall over a few hours. So basically using the highest temporal resolution feature to ensure the currently uninsurable risk. Why is it important to invest in our proposal? Our research helps to promote a sustainable business model. In this model, circular providers, once informed of demand, they would provide CML data on a regular basis. And entrepreneurs and researchers can use this data to design rainfall products. And this data would be used by the end users, such as donors, farmers, microinsurance providers, etc. We also have strong stakeholder buy-in in Guatemala. Both the insurance providers and FieldNet have expressed high interest in collaborating with us. And this research has represented a novel collaboration between the geoscientists, engineers, and economists, which makes such research feasible. Thank you.
Thanks. Okay, so that was a frustrating session for me. I'm used to using a lot of superlatives, and I had to remain neutral and calm in the handovers. But now that we've heard the 7, I must say that was just wonderful, right? I mean, that was 7 great ideas, which did amazing things in the pilot stage, and now have some really concrete plans of how to move this forward. I can say, for the judges, this is going to be a nightmare. Every year I think the quality of these things is just getting better. The quality of the presentations, the visualizations. Oh my God, there were some nice ones there. So wonderful to hear all that. You've got more chance to interact with these people. There were some excellent comments up there on the Menti. There's going to be the booths over there, and the people will be available. All the pitchers will be available to answer any questions you have. So I'd like to hand over to our master of applause, Brian, where we'll do a little recognition of the quality of what we just heard in 07.
How's everybody doing? I said, how's everybody doing? Yeah, those were pretty great, huh? How many people in here have applied for an Inspire challenge? Hey, look at that. How many people want to apply for next year? There you go, cool. So I'm here to tell you a little bit about what's happening this afternoon. We've got lots of really awesome stuff going on, as Andy alluded to. Right now, we are early, and we're going to use this time to take a group photo. So as soon as we break, we're going to go out these doors and around the tent into this courtyard back here, and we will all be directing you that way. So please follow the crowd. It should take 5 minutes. Then we're done. We're going to be using the drone, so it should be a cool picture. After that, we have the full hour for you to have lunch. Then exploration starts at 1 sharp, so if there are exploration activities that you're excited about, please, please, please go to them at 1 p.m. 2 p.m. starts the COP sessions. We have the technical sessions. The deep technical sessions are going to be an hour and a half long. That's the first breakouts. And then after that, we have the engagement sessions where you can learn more about the communities of practice. So to recap, photo, lunch, exploration hour, then COP technical sessions, then coffee, then COP engagement sessions, then reception and street food. So, break.
Oh.